All right, well, our visiting Kansas bike here is on its last step, which is to sync the carbs. So you may be wondering, do I need to sync the carbs when it's running? I did a bench sync, so everything should be pretty good. Well, I'm going to tell you, you need to do a running sync on these because these carburetors are old, the bikes are old, the compression on the two cylinders is a bit different, and yeah, you'll get it running, and as you could see in that initial ride video I did, it ran okay. Just had a little popping and things, but we want to get rid of all that and give it all the horsepower that it can get so it can run good. But I'm going to sync them today, but what I wanted to show in the video is the three basic ways that we sync the carbs. And so we can use gauges, we can use a little bottle type, and then we can use just a loop type manometer. And we're going to go through some physics as to why, because I got my little board over here. We're going to talk through what's going on with syncing these carbs and why each one of these works, and some of them don't work very good at all, like the gauge, for example. So we'll go and set up all this stuff and we'll go through these and then you'll see. But if you wanted to sync one and you're just curious about it, there's another video out there. It's really easy. Here's a set of carbs and it's just that little screw right in the middle to sync them together. And then on the first gens, you got a little lever on the side over here that you have to sync right here for the idle, because it has an idle sync and it has a run sync on the first gen. Second gen's a lot easier, but we'll get set up over here. If you want to see that, there's another video out there on how to sync these things, but we're going to talk about the different types of gauges or setups that we can do to sync these carbs. All right, so just what's going on when we're syncing these carbs? Well, we're going to have to put our physics hat on to kind of understand some of these differences in the way we can measure it. Now the gauges are pretty easy. They're supposed to be calibrated. If you got the cheap ones, I'll show you that they're not, and they're not very helpful at all on syncing your carburetors. The bottle and the tube manometer, they actually follow physics. They do a principle here of where you're balancing vacuum between one side or the other. Now for these V-twins, it's really easy. You just got two carbs, so you can hook up one pipe to one and one to the other, and you can balance the two out. If you got four cylinders, now you're going to have like a bank of tubes, like a tube manometer bank, and you'll balance all four together. But for two, it's super simple. But let's get into a little bit of physics as to what's going on, and you'll understand once I get over here and show you these bottles and the tubes and the gauges. You'll see why it's important and why some of them will work and why some of them are just overkill. All right, so over here in America, we measure vacuum in inches of mercury typically. And we use mercury for measuring any kind of vacuum because it's really heavy, so you don't have to have a lot of it. If you were doing it in water, you're going to have probably 13 times the amount of height in your column than you would with mercury, because mercury is really dense and it's really heavy, and we're going to see why density is the factor that we use when balancing with a manometer. So if we look at the density of mercury, it's 13.6 grams per cubic centimeter. So it's pretty heavy stuff, we all know that. If you look at the density of motor oil, it's about 0.9 grams per cc. So mercury is about 15 times heavier than the motor oil. Well, what does that mean? Well, that means an inch of mercury in a column, so like a real manometer that's got a mercury in it, that's going to equal 15 inches of motor oil. So if I pull a vacuum down and I lift the mercury 1 inch to simulate 1 inch of mercury on the vacuum, that's going to equal 15 inches of lift of motor oil because the density is so much less. So we see that for our setups on these over the years of doing it, I'm pretty good if I'm plus or minus about an inch of motor oil in my tubes, because I use the little tube manometer. And so about an inch, I'm in good shape. It kind of ditters around, you know, because the cylinders are hitting. But you get within an inch, you're good. So what does that mean if you were looking at inches of mercury? Well, if you do the math on that, 1 inch, flip it over, and you're going to see that you're looking for a 15th of an inch change in the inches of mercury. Well, those gauges over there, you'll see they're only incremented by maybe, if you're good, a ½ inch of mercury. But you got to get such a tiny little measurement out of the difference on those two gauges, you're not going to be able to pick it up very good on the gauge at all. So that's why the gauges, unless you got some really good gauges and you spend a whole lot of money to get them, these $15, $20 gauges right here aren't going to do anything. So what we got here, and this is a statement that I'm going to say because I went to school and so I learned this stuff in physics. But for a manometer, only the column height matters. It's not the volume of the amount of fluid that you're using. So if you look at the bottle thing, when we get over there in a minute, you're going to see there's a lot of volume of oil. In my case, it's that Marvel's Mystery Oil because I like it because it's red. But that stuff is a whole big volume of it in those bottles. Well, it doesn't make a difference how much volume you have of it because a manometer is only measuring height. And if you want to know why, here's some math behind it. So we'll look at the calculation for how you're going to arrive at pressure. So pressure is equal to force divided by area. So F is force, A is area. All right? If you got force, force is equal to the mass of something times the gravity of the earth. So you got force is mass times gravity. If you substitute in over here for force, you get pressure is equal to mass times gravity divided by area. All right, so it's kind of like a volume thing, right? Well, if we look at density, mass is equal to density times volume. And that's where the volume comes in. So you can calculate the mass of something by its density and how much you got. So little p is density and big V is volume. Sub those in and you're going to end up with pressure equals density times volume times gravity divided by area, right? All right, so volume, the last one on the list here, volume is area times the height. So it's the area, surface area of something times the height of that area. So it's like a column, right? So A is area, H is height. If you plug those in, then you end up with pressure equals density times area times height times gravity divided by area. Well, area cancels out. So really, pressure is just density times height times gravity. So that's why I say it doesn't matter how much you put in there volume-wise, it's just the height. Because the manometer uses the area on top, and when you pull a vacuum, the bigger area has a bigger surface area on top, the vacuum can pull harder. So you could take 2 5-gallon buckets, put them over there, and you could balance the carburetors with 2 5-gallon buckets, and it would move it up and down an inch, move it up and down 2 inches, etc. But it's going to take forever because it's a whole lot of volume of fluid. So that's why over here on the tube manometer, you'll see when I pump it up, it moves really fast. The bottle one doesn't move very fast at all, but at the end result, the height of the difference in the bottle is exactly the reading that you're going to get for the height of the difference on the tubes. So we'll go over and have a look now that we've done our math, and we can see that the only important thing really is the height that you're moving the bottle or the tube. Now for the gauges, it's really important on the calibration, on the cost of the gauge, etc. So let's swing over here and we'll look at each one of them, and then you can see why I always end up using just the Tube Loop Manometer, because number one, it's cheap, and number two, it works better than most every one of them. All right, so we're zoomed in on the gauges here, and so I got them set to 0, and these are some cheap gauges. And like I say, you can do it with gauges if you want to spend a ton of money. You want to get some good gauges, but these gauges right here, you can see the increments. So here's 5 inches of mercury, and so there's no increments between. But on the board over there, if you remember, to get a decent tune, we got to get a 1/15 of an inch. So you're going to have a whole lot of trouble seeing a 1/15 of an inch right inside of there of mercury. So let me zoom back out. We'll hook it up to a gauge, and then I'll also show you why these aren't going to work very good at all. So we'll zoom back out a little bit, and what I'm going to do is hook up just a little vacuum bleeder to it. And so if you watch the gauges, when I hook it up, if I can keep them still, when I pull it down, I'll just pull down, say, about 5 inches of mercury. So right around there, more or less 5-6 inches of mercury. Well, if you look on the gauges right here, you can see this one's right about 6. This one is under 6. And so it's the same gauge because I got it just a loop right here. They should be reading exactly the same, but because these gauges are cheap and they're not calibrated very well at all, one gauge isn't going to read the same as the other gauge over here. So if I was using these to tune, I would actually tune this one to come a little higher, this one to be a little lower, or just tune them both the same. But it's not doing me any good because they should be exactly the same because they're pulling the same pressure. So this is one of the big reasons why you can't use these. Now I use them, I hook them up on the motor just to see if the cylinders are firing good because they'll jitter when one of them's not firing good. we can see what's wrong. But you can't use these to sync your carbs. So if you have used these things and you say, oh, my carbs are synced, I got them synced by the Gages, you didn't sync your carbs. All you did was just got them kind of close, but you could do that listening to the bike running versus using these gauges right here. So these gauges are out. I don't use these for syncing at all. And this is exactly why, is because they're not reliable, they're not repeatable, and you can't get any kind of distance here on what you need to get the carburetor synced because you just don't have enough increment right there. So now we'll move on to the little bottle guy and we'll see what's going on with him. All right, so moving on to the little bottle type right here. Now he's pretty cool looking. It looks kind of like a science experiment or something, like you know what you're doing. But since we found out from some physics over here, it doesn't matter how big the bottle is, how pretty the bottle is. It matters that the bottle's sealed up for sure, and it matters about the height. So the height of this is all you're looking for, but because of the way physics works, a 1-inch height difference over here is exactly equal to the vacuum of a 1-inch height difference over here on the little tube. The tubes are so much simpler, doesn't take all this, but if you want to impress your friends, you can make some little bottle guys like this, and you can say, oh yeah, I got my carbs tuned. Well, yes, you can tune your carbs very well, but I'm going to tell you, when it comes from bench sync over to a running sync, with only 1 inch of movement, you know, you got about 2 inches before the bottle fills up, you're going to really struggle because you're not going to be that close to start with, and you're going to suck all the fluid out of one bottle, put it in the other bottle, and if you have your stingers too low down in here, you got to make sure they're not all the way in the bottom. If you have them too low, it's going to suck all this down in your motor. So then you're going to have a ton of oil down in your motor, and you're going to be cleaning all that out, letting it run for a little bit. But this guy right here, 1 inch here is equal to 1 inch over here on both of these different ways of doing it with a manometer. So really cool, looks good, kind of impressive, but why go to all that trouble? Because physics tells us it's doing exactly the same thing as that little tube manometer over there. So what I'll do is hook it up so you can see that it doesn't make any difference on how much volume you have. It's all about the height. So what I'm going to do is hook my little pumper into here, and what I got is one side is going up to the loop manometer, the other side is going over here to the bottom. So when I pull the vacuum down, they're going to move, and you can see, I don't know if you can see on the video very well, but right there's the lines for here, and of course you can see them really well there. So when I pump it up, and so I pull a little bit, you're going to see them move. Okay, well this one moved a little, I'll have to pump it up a little more. That one moved a lot, but then as you see, it stabilizes back down to exactly the same level that this one's going to be. If I pull a little more, and I get more vacuum on it, you can see I'm not even pulling, if you look at this gauge right here, I'm not even pulling an inch of mercury, and it's making that much difference on the bottles. That's why these gauges over here aren't going to tell you squat, because I can't even get a reading on this gauge right here, and I'm already showing that I'm in balance. So I'm going to pull up a little more, and we'll get it pretty well in balance. So right here, you have a difference of about, I don't know, about an inch. Over here, you can see that the gauge moved a lot because there's not as much volume, so it reacts a lot quicker. But as it goes back down, you're seeing these guys slowly go back down, and they're going to stabilize exactly the difference from here to here will be over here to here. And that's because that's the way the math works, and that's the way physics works, because it doesn't matter how much volume, it's all about the column height. So as we stabilize, you can see here we're at an inch, and here we're right at about an inch. So it doesn't matter which way you do it. This one over here, for the loop type, it gives you a big spread. So you can be off, you know, up to an inch of mercury, because you got 15 inches in your column here easily. You can make it as long as you want. You can be way off on your sync, still not gonna be off range so bad that you pull all the fluid out of the little bottles. And the other good thing is if I disconnect it, so when I pull this back off, okay, everything's gonna go back to ambient gravity on both sides because it's open on both sides now. These tubes are disconnected. Well, you see how quick this one went back. It went back really, really fast. Well, this one is not moving. Now, if we sit here for another 10 minutes or so, it's slowly going to work its way back down and it'll bounce back. So the other good thing about using just an old cheap tube manometer like that right there, throw you some motor oil in it versus something like this, or you could use like the Marvel's Mystery Oil if you want to see the colors in there. But the biggest thing for that is that it reacts quick. You got a big column to play with, so you can be off quite a bit and you won't suck all your stuff out of your bottle. So the bottles are cool, but they're doing exactly the same thing as this little bitty tube right here because it's all based on height. So now we can figure out which one we want to use. And like I say, if you're really close, you can use this one. It's not going to pull all your fluid out, but if you're off quite a bit, you can notice that the bike's not running. Why even go to the trouble to have to do this? It sucks all the oil out. You got to redo it, sucks it down in the motor. Worst case is over here, you're going to suck that little bitty bit of oil into the motor if you get it too far off. But the odds are so much better because you have so much more distance to play with on the sink before you suck everything dry. Keep it in mind that 1 inch over here is going to tell you exactly the same as 1 inch right here. All right, so for the folks that doubt the math, let me zoom in here real quick. What I'm going to do is fire it up with these manometers, and you can see the line right there about 0. I'll fire it up and show it's out of sync, and then I'll switch back and we will go down here to the little bottles and I'll show you the difference between these two because it's going to be out quite a bit. Probably when I go to the bottles, it's going to suck all the fluid out, and you'll see that it's so much easier just to use this type manometer than it would be to use the bottles. So let's fire it up and see just how far off it is. All right, so as we can see, it's off quite a bit. I put my fingers up there just in case you couldn't see. So now what I'm going to do is I'm going to switch over to the little bottles down here, and we're going to see, because that's not too far off. It starts and it runs, everything's pretty good, but it's not synced. So let me switch over to the little red bottles, and we're going to see what the little red bottles tell us for that much difference, because that was several inches in the tube. And if the math is right, I only have about 1 inch or so of the red stuff down here. So it's going to suck every bit of that out of that little tube right there. And it's going to just sit there and bubble, bubble, bubble. So let me get this one hooked up real quick. Then we'll fire it back up before we sync it. Alright, so we haven't adjusted the sync, but what I did is switched over to the little red ones over there. So now when I fire it up, let's see what the red ones do for how much it pulls down. You got to keep in mind the red fluid is really slow because it's got to pull it through the pipe. And little by little, it's dropping down. That's why I say this is much more difficult to use because it doesn't react near as fast as the little tubes do, but little by little, it's pulling down. And you'll see it's going to get much further than 1 inch to the point that the little tube comes out, and then it starts sucking bubbles. So then you don't know what to do. So you can sit there and tune back and forth, but it doesn't react very quick at all with this bottle type versus over here. You can see how quick it jumped up and showed that we were out of tune. There went the bubble. So you can see how long it took it to actually pull that down, but it would have continued because my little pipe ran out of the bottom. And so it started pulling bubbles. So basically, now my setup is messed up. I got to pull the fluid back over, but you can see how long it takes. You have to sit there and wait and wait and wait and wait and wait. Whereas over here, and I'll hook it back up just to show you one more time how quick the tubes react over there. And you're going to see, well, the tubes are so much cheaper. And yeah, they're not as pretty as the little bottles, but they work so much better than trying to do it with the bottles because you're just not going to get a reaction that fast out of those bottles. And we saw for the Gages, they're pretty much worthless. So Let me switch the tubes back over, fire it back up over here, and you'll see how quick those little tubes react. So I'll just zoom back in here while I'm swapping it over so you can see the little lines again. All right, so now we're back over to this one. And so when I fire it up, you'll see just how much quicker you can get a reaction out of those pipes. Quick it jumped from there to there. That bottle's taking forever, but eventually it would do the very same thing. It will show you the same pipe. Unfortunately, the bottle is not near deep enough, so after 30 minutes of waiting, you would finally get that far off of your sink to know that you're out of sync. Well, alrighty, there you go. There's the difference in using the little red bottle versus using just the tube manometer, because the little bottle takes forever to pull down and you don't have near as much distance to play with, so it's so much harder to get a tune when you're off just a little bit from your bench sink. Well, alrighty. Well, thanks for watching.